Here we go, folks. We're going to look today at a two-point interference pattern. So that's what this is called. This is called a two-point interference pattern. And so what I'd like you to get a sense of here is this is a source right here, source number 1. This is a source here, source number 2. And it's the idea of, if you can imagine, this is a source where it vibrates up and down and it's making ripples in water. So it's a wave generating system. And so this one goes up and down and it creates a crest and another crest and another crest and another crest and another crest. And they just are radiating outwards from the center of this disturbance. Over here on number 2, the same idea, crest, 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 crest. So this is a wave generating system and it's 2 points, each creating waves. And so what we're looking for is the interference pattern that is created when these 2 points are going to create waves from each one. In order to fully understand this pattern, what we need to understand is that this is only showing us right now in the diagram half of a wave. It's only showing us the crests. What is the other half of the wave we need to know about? The troughs. So what I'd like you to understand is I'm not going to worry about the bottom half of this diagram. So I'm only worried about the top half. We can just kind of ignore anything below because below is just a repeat of whatever is above. So if you can also use the below part as a practice in the future if you wish. But right now we're going to worry above. What you're going to have to do is using a pencil or a pen, you're going to have to put in the troughs. And so I'd like you to try to tell me, where do you think the troughs would be if this is a crest and 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 this is a crest? Where would the troughs be? Halfway between. Oh, little trivia question. How do you spell trough? Oh, Edward. Yes. Thank you very much. T-R-O-U-G-H. So what we're going to do is we're going to, as best as we possibly can, we're going to, and it takes a little bit of practice, we're going to sit there and draw dashed lines in halfway between the crests for every one of the concentric circles from source 1, and you need to also do it for source 2. So this takes a little bit of practice and a little bit of time, but as you see, once you kind of get used to the concept, it's not very difficult to do. So I'm going to give you a minute now just to draw in all of your troughs. I'm done now. So here we go. We now have a crazy make your eyes go loopy kind of diagram, and you go, thanks, Mr. Wright, that sure sounds like a lot of fun. What we're going to do now is remember the point of this diagram is to look at the 2-point interference pattern. 2-point interference pattern is saying that there's interference happening between these waves. These waves are all going, and you notice they're crisscrossing and meshing together. Wherever the waves are crisscrossing, there's interference. Because waves are a continual energy wave disturbance, there's actual interference right across this entire page. What we're going to look for is the interference that we can see the clearest and easiest. And so what we're going to look for is the 2 types of interference. There's 2 types, and what are they? There's constructive interference and destructive interference. When is constructive interference going to happen? 2 crests or 2 troughs. When does destructive interference happen? 1 trough and 1 crest. So we're going to look for, first of all, constructive interference. And for me, what I'm going to do is I'm just going to start halfway between source 1 and source 2, and I'm going to look for where the crests are meeting up with crests. So halfway in between, I see, and I'm going to put a dot on here, and if you have different colors, that would be a nice thing to add to this. I'm going to put a dot right there where those 2 meet. And then what I'm going to do is I'm going to go straight above that, and notice that I see another X straight above that, and another X straight above that, and another X straight above that, and another X, another X, and another X. And so I have a series of 1, 2, 3, 4, 5, 6, 7 red dots straight up the middle. Okay, moving on. I'd like to remind you what you just told me. Constructive interference can be 2 crests or two troughs. So I'd like you to see that we've just found out where all the crusts interfere, but I'd like you to notice that between this red dot and that red dot is actually an X of two troughs. And between this one and that one is an X of two troughs, and that one, and that one, and that one, and that one. And I know I wasn't perfect in my middle placement of those troughs, but now that I look at it in this aspect, I wasn't too bad. How about you? Okay, now that we've done that, I'm just going to veer a little bit to the left, and I notice, and this is just the way my eyes work, I see these X's again. Do you see the X's as well? And so this is how I do it. I find the solid X's, and then I go back and see that the dashed X's actually exist in between. And I can do that on the left. And then I'm also going to go to the right and see a series of solid X's for the crest interfering with crest, creating constructive interference. And then I'm going to go back and say, I missed that one totally, but really that's the middle point there. Even if I missed it, now that I see where the solid lines cross, I can see a much clearer picture of where the dashed lines should be crossing. And so now I've got three radiating sets of dots. How about you? Okay, so I see something here that I'd like to just continue on with, and that is I see a series of radiating dots, but they aren't random at all, are they? Even though when we first looked at this pattern, it seemed random. I'd like you to notice that this dot right here, these solid dots, are actually constructive interference of crest on crest. What would that look like? What would a crest on crest look like if it's constructive interference? Bigger? Okay. This would be, and again, we've talked about this before, this is really what we would say is a doubly high crest. Even though we know that's not true, it won't actually truly be double, but just for simple sake, we're going to label that as a big capital C because it's representing a very large crest. So every one of these is a large capital C because it's a doubly high crest due to constructive interference. Next, over here, and I'm just going to the other side, I also have an example right here of where a trough meets a trough. What would that look like? Doubly low. So I'm going to write this as a capital T, or label it with a capital T, and so we can recognize that this is a point where the trough would be twice as deep, or doubly low. So really what we see here, folks, then, is if you look along the line, it's a doubly high crest, a doubly low trough, a doubly high crest, a doubly low trough, a doubly high crest, a doubly low trough, and so on. So we get a point of extreme wave phenomenon here, or a place where there's lots of wave energy. Fair? Okay. Now I would like us to take us to the next piece and say, now this pattern actually radiates in fairly much a straight line. And what I'd like to do at this point is I'd like to take and actually connect the dots. That's that burning yearning desire as a scientist to say, if I see a pattern, I want to recognize that pattern. And I'm going to draw out my pattern. And my pattern is a nice series of straight lines. These lines actually have specific terminology or names with them. This middle one is called the central maxima. And you'll notice this one on the next side, this one is called the first order maxima. Same as the one on the right-hand side. First order maxima happens on the left and it happens on the right. Now that I've seen this pattern, I'm actually able to look and say, well, we had the pattern on the left, we had the pattern on the right. If I start turning my vision to the left a little bit more with my ruler, all of a sudden, I'm actually able to see that this pattern repeats itself again. Do you see that happening on the left-hand side? This is called the second order maxima. If I keep going to the left, all I'm looking for is the x's. I can actually find another series of lines right there. What do you think that one's going to be called? This is called the third order maxima. I can go left again and see a series of x's, and there it is there. And I can go left again and see another series of x's and trace that out there. So that gives us a fourth order maxima and a fifth order maxima. Are you okay with this concept so far, folks? So moving on, what we have here is we understand there's maximas there, but we now need to investigate what's going on in between the maximums. So this is the way I do it because I find this pattern too hard to look at. So I'm just showing you the things that help my eyes figure it out. So the next thing I'm going to do is I'm actually going to look in between the central maxima and the first order maxima, and I'm going to see something that happens here where right here, right there, right there, right there, I'm seeing a place where what is happening? Can anyone tell me what's happening where I'm circling? Crest and a trough, which is what? That's our destructive interference. Remember we said we're going to look at constructive and destructive? I find it easier to find the constructive, and then I am able to find the destructive because the destructive happens between the constructive. Fair enough? And so we have a special name for this. This place where we have a crest meeting a trough, it is called a node. N-O-D-E. Node. The node in this case is very important to us because this node is actually a place of perfect cancellation. Because the waveforms are in complete agreement, we actually get a trough the same size but opposite of the crest meeting, and we actually get flat water here. It looks like there's no wave in the water at all at this point. So we have these extreme bump points and then flat water in between. Extreme bump point, flat water in between. I'd like you to notice that also these line up. And we can draw a line through them as well. And this line is not a maxima, is it? This is actually a minima, isn't it? But we don't call it a minima. We call this a nodal line. Now, you might be asking, why is this important? Why are we doing this? Like, what the heck's the whole point of that? And the whole point of it is when we go back to this demonstration I showed you folks a little while ago. I showed you the idea of laser light going through interference slits. And if you have laser light going through an interference slit, I'm just hoping this will work. I don't know if it will in the light like this. But you get to see patterns, and I have to be further away, I think. But you can see that there's a central bright part, and then there's actually black gaps in between, and then another bright part, and so on. You guys can't see it? No. Okay. Well, I'm going to turn off the lights and try. What that means, folks, is when you look at that, that's why when you put the laser through the double slit interference grating, you get a central bright light, and then black, and then another bright light, and another bright light, and then black, and then another bright light, and then black, and so on. And so that's where this pattern is generated from, is from the concept of a two-point interference pattern.